All right, so step one, we're dealing with quadratic equations. So we have a form where it's y equals ax squared plus bx plus c. So it's important to write them in decreasing degrees. So x squared first, and then x, and then the constant. All right. The letters A, B, and C we're going to use throughout this part with factoring, and then when we get on to using the quadratic formula, which is next week or the week after. So this is our standard form, ax squared plus bx plus c. We've been dealing with multiplying binomials like 2x plus 1 times 3x plus 5. So we've been dealing with that. No matter which form you want to use, we're still going to distribute, get 6x squared plus 13x plus 5. So we've just been distributing, going from two sets of parentheses to one general equation. But what's going to happen is now you'll be given 6x squared plus 13x plus 5, and you'll be asked to factor it. Factoring means break it up into two sets of equations, which will be used later to find zeros and help us graph the equations. So this first method is called factoring by grouping. So factoring by grouping. Okay. The first thing you do for factoring by grouping is to take your a value, the number next to x squared, and multiply it by your c value, the constant. So as you can see in our standard form, a is the number next to x squared, c is the constant, the number by itself. So for this, a is c, well, a is 6, and c is 5. So what is a times c? 30. So the first step is to do a times c and get 30. Once you've identified AC to be 30, what you now need to do is find the multiples of 30 that add up to 13. So if you have to, write out the multiples of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Once you've identified all the sets of multiples, which ones add up to 13? 3 and 10. So what we're going to wind up doing is we're going to rewrite 6x squared plus 13x plus 5. What we're going to do is we're going to break up this 13x here into our 3 and 10 combination. So we're going to write 6x squared plus 10x plus 3x plus 5. If you write 3x first and then 10x second, that it doesn't matter. It's going to work out to be the same. Once you have these four things written, put the first two in a set of parentheses and put the second two in a set of parentheses. Once you have the first two in a set of parentheses, you have to take out the greatest common factor of both. So I have 6x squared plus 10x. What is common to both 6x squared and 10x? A 2 and an x. So you can take out a 2x from both. If you take a 2x away from 6x squared, 6 divided by 2 is 3. You had 2 x's. You took 1x out, so how many x's are left? 1. So 3x. For the second term, I had 10. I divided by 2, and I get 5. So plus 5. I had 1x. I took 1x out, so how many are left? None. Good. So just close your parentheses. Write your plus sign. Is there anything I can factor out between 3x and 5? No. All right. Normally, I don't like you writing ones in front of parentheses, but it'll help you in the long run. So I'll let you write a 1 here and then a 3x plus 5. All right, so we're almost done. Notice how the 2x is pulled out, and there's nothing you can factor out from the 3x plus 5. You pulled out a 1, and there's a 3x plus 5. So the big thing here is this term, this 3x plus 5, should match up to the other 3x plus 5. If they don't match up, something went wrong. Okay. What we're now going to do is factor out that 3x plus 5. When we take away the 3x plus 5, what's left in this first term? Just the 2x. And when I take out the 3x plus 1 from the second term, what's left? The 1. So that winds up being the factored form, 3x plus 5 times 2x plus 1.